Today we discuss about that Sn2 reaction, that is another nucleophilic substitution reaction, that is Sn2. That last class we discuss about that Sn1 reaction. Here we discuss about that Sn2 reaction with mechanism. So in this case you have to take the primary alkyl halide group. Here this is a primary alkyl halide, okay. In the presence of, it is a another nucleophile, attacking of nucleophile in the presence of non-polar solvent DMSO or DMF. DMSO or DMF, then it form always inversion product. Inversion means complete opposite of the another halogen, means this is a nucleophile replaced by this nucleophile, but it should be opposite direction. So here it form the inversion product. This is a Sn2 reaction. So complete opposite. If it is this one is a chiral, we get 100% inversion product. So in this case, it is the first. It is involving only primary alkyl halides. Why? What about that secondary and tertiary? Because it is a repulsion is possible. So whenever it is attacking, it should be free space. If it is a primary, if it is tertiary is there, like CH3, then CH3, then CH3 is there. Here attacking of nucleophile is not possible because steric names, like here CH, H, H, then C, H, then H, then H. Here C, H, H, then H, X. Here steric intense is present, so that tertiary alkyl halides is not possible in Sn2 reaction. It should be primary alkyl halide. So here we are taking the primary alkyl halide. Then another one is here this reaction forward by that is non-polar solvent DMSO or DMF. DMSO means dimethyl sulfoxide. Dimethyl sulfoxide. Then DMF means NN dimethyl formamide. NN dimethyl formamide. This is a DMSO. This is a DMF, dimethyl sulfoxide. This is SO, the NN dimethyl formamide. This is a non-polar solvent. So it is a single step reaction. It is a single step reaction. So previous one Sn1 is a double step. It is a two steps reaction. Here it is a single step reaction. Then another one is, in this case it does not form any intermediate. No intermediate. It form only it form only transition state. So it form only transition state. It does not form any intermediate, it form only transition state. Then one more very important is rate of reaction depends on only primary alkyl halides and the nucleophile, both. Rate of reaction depends on primary alkyl halides and nucleophile. So here this is a rate is always depends on primary alkyl halide as well as nucleophile, both. So that here the order is here 1 and 1. So it is order is here 1 plus 1. It is here 1 plus 1. It is a 2. It is an example of second order reaction. It is an example of second order reaction, that is a chemical kinetics. Now we discuss about that mechanism. Then after that we discuss about that reactivity order. So here I will discuss mechanism. Here HCHX, it is a OH minus, then DMF as a solvent. It is always attacked to the complete backside. So here OHCX, then H, then H, then H. This is always you have to write on transition state in square bracket. This is we are calling as a transition state. You have to write on in square bracket. This is a here hybridization is sp3d. This is an exception case. So exception. Then trigonal bipyramidal TPP geometry. In previous case Sn1, that is sp2 planar geometry, but Sn2 sp3d exception case we'll discuss later. Then trigonal bipyramidal is a geometry. Then here this is a dotted line. It shows bond breaking. Then this dotted line it shows bond making. So bond bond breaking and bond making simultaneously, so that generally we are calling as a transition state. So it is actually slow state RDS, rate determining step. Again here this is a fast step, so fast step loss of x minus, then here OHC H plus x minus. This is a inversion product. This is a Sn2 reaction mechanism. First we are taken alkyl halide, then after that, which is treated with the base in the presence of a non-polar solvent DMSO or DMF, then OH minus attack to the completely backside of the halogen, because it is a Sn2 reaction, nucleophile attack to complete backside of the halogen. Here this dotted line showed bond making, this dotted line shows bond breaking. So here this is a transition state. Now I will discuss that reactivity of the Sn1 reaction, Sn2 reaction, reactivity order. So always primary alkyl halides are more reactive than secondary alkyl halides, then tertiary alkyl halides. Why tertiary alkyl halides are least reactivity? That due to that steric index is possible, it does not attack to the complete backside in tertiary alkyl halides, so that it is always a primary is more than secondary than tertiary. It is complete opposite of the Sn1 reaction. This is a Sn2 reaction mechanism. Thank you everyone.